Hello, today we are going to be working on reduced row echelon form. We're mainly going to be doing this on the graphing calculator, but we're also going to look at how we can solve systems with this and other methods. So there's a lot of different ways to solve systems, and using the reduced row echelon form on the TI calculator is just one of the ways we can solve systems. So let's take a look here at this system of equations that we have right down here. And we are going to solve this for x and y. Now, we have a lot of different methods. We can use substitution, elimination, we could use graphing. But today we're going to take a look at that reduced row echelon form. And we're going to start off, we're going to solve this by doing it by hand with the reduced row echelon form. And all this means is that we're going to get this written as a matrix to start off with, and then we're going to solve it by using that matrix and getting it into this certain form that we call reduced row echelon form. So we are going to, when we do it on the calculator, there's actually a button on there. We're going to input the matrix, then we're going to go to matrix math, and we're going to scroll down to RREF. And that stands for that reduced row echelon form. We'll go back and find the matrix and we'll put it in. And I'll show you that here in just a minute. So for example A, we're going to solve the system using reduced row echelon form, first without the calculator, then with the calculator. You will not have to get a matrix into RREF, reduced row echelon form, without a calculator on your own in this class, but it is a good concept to see. It's something that comes up in college, especially if you take a course called linear algebra. There's a lot of work with reduced row echelon form. So when we get a matrix into reduced row echelon form, it's going to have this pattern right here. So we're going to start off by writing the matrix as a 2 by 3 matrix, and then we are going to get it into this form. It's a 2 by 3 matrix. And it's going to go 1, 0, x, 0, 1, y. So as soon as we have a 1 in that spot, that represents the x spot. So it's 1x plus 0y equals some number that we're going to solve for. The second equation would be 0x plus 1y equals some number that we're going to solve for. So you can see that now we would actually have x equals a certain number and y equals a certain number. So that's the reason for trying to get the matrix into this manner. Now, when we're doing reduced row echelon form, we can do any type of combinations like we would do with elimination. Basically, we're trying to get a 0 in the top middle part, and we're trying to get a 0 in that second row first column part. So I'm coming down here and I'm writing this matrix as a 2 by 3 matrix, just using the coefficients and the constants there on the right. So we write the matrix, and we're now going to try to get everything, the zeros in those two spots that we just talked about a minute ago. So I kind of like to draw a dotted line down here just to separate my variable coefficients from my constants. And I'm trying to get a 0 in that second row, first column to start with, right there. So all I would have to do to make that happen is subtract those two rows. And so the first row isn't going to change at all. That first row won't change. And I'm just going to rewrite the first row, 1, 2, 8. But that second row, I'm going to use a combination. I'm going to take that first row and I'm going to subtract the second. So 1 minus 1 is 0. 2 minus negative 1 is 3. 8 minus negative 1 is 9. And that's the same type of thing we could do if we were solving this by elimination. So you can see that we still don't have it in that correct form. We want a 1 in this spot, and we have a 3. So what I can do is I can divide that entire row, just that row right there, by a certain number. So what would we want to divide it by? 3, right? If we divide that row by 3, and just that row, we don't want to divide the top row by 3. That's going to make it messier. So dividing that second row by 3, I'm going to get 0, 1, 3. All right, so now I've got my second row is exactly the way I need it. And basically that's saying 0x plus 1y equals 3. So therefore I know y has to equal 3. And so we've got that part of it done. Well, now we still need to know what x is. And to know what x is, I've got to get rid of that 2. So if we think about it, if we multiply that second row by 2, actually by negative 2, multiply it by -2. And I'm not going to change that second row, though. The second row is actually going to stay the same as it is, 0, 1, 3. But I'm going to take that other name for that second row, and I'm going to add it to the first row. And so I get a 0 there, and I get 8 minus 6, and that's 2. So now I can see that I have 1x plus 0y equals 2. And I've got it in this reduced row echelon form. So therefore, x is going to equal 2. And we've solved the system by doing this reduced row echelon form. Again, you don't have to be able to do this on your test or quiz or anything in here, but you will need to be able to solve the system using RREF on your calculator. And I think this is a really nice thing to see because it's just understanding the patterns of math. All we're doing is solving this basically the same way we would solve by using elimination. Now I'm going to show you on the calculator. So we're going to start off, we're going to go to our matrix. So find the matrix key on your calculator, second x to the -1. You're going to go over to edit, and we're going back to our original matrix, and we're going to solve it on the calculator. So the original matrix that we had written is a 2 by 3 matrix. That's the original matrix right there. So I put that one in. First, I have to tell the size of it. It is a 2 by 3. Putting in the numbers 1, 2, 8. 1, -1, -1. All right, so now I want to quit out of there. I want to make sure my home screen's clear, and it is. Okay, so now I want to find RREF. That's going to be under math. So I go back to matrix, I go over to math, and I have to scroll down until I find that RREF. There it is right there. So I'm going to go to RREF, I'm going to click enter. Now I have to remember where I put that matrix, and that's in matrix A, and close the parentheses, you don't even have to. And now it gives me that reduced row echelon form. So I can immediately see that my solution is x would have to be 2 and y would have to be 3. It's getting it, it's doing all the manipulations for us and getting it into that correct form. So it's really a cool method to use on the calculator. We can have very difficult systems to solve, and the calculator can just do all those manipulations and get it into the correct form for us very quickly. All right, so in a minute, we're going to look at one of those more difficult ones. It's going to actually have 3 equations and 3 variables. But I want to go back for a minute, and I just want to show you how to do this problem if we had used, well, actually, we'll go on to the next one. Let's go on and take a look at this one. This one is going to be a 3 by 4 when we get to it, but we're going to go back up to the top, and we're going to solve this one by just solving it with elimination, not using a matrix or anything, but just instead of using that reduced row echelon form like we did before, we're just going to solve it just by using elimination. But you can see that it's going to end up being that exact same process. It's just that we kind of forget about all the variables. Whereas when we're doing that reduced row echelon form on our own, we get rid of the variables and we solve it, and we're just getting it into this certain form that we need, that 1, 0, 0, 1 on the left-hand part of it. And we just kept going, we combine, but it's basically just using elimination to solve. Okay, we're always allowed to add, subtract, multiply, divide, use any of our basic operations. So like in this step in particular, I had to multiply that second row by -2 and then add the 2 equations in order to get that 0 to be in that first row, second column like I needed. Okay, so you can go back and review that if you need to, but it's basically just elimination, and we're just not worrying about the x and y. All right. So now we're going to take a look at this. I'm going to solve it just with elimination. I'm going to keep the variables in there and show you what happens. So I'm just rewriting the equation, but I multiplied that second equation by -1 at the very beginning. And now I'm going to add the 2, and you can see how much that looks like what we did up above. And we're going to get 3y equals 9 and y equals 3. And so therefore we know what y is. And we found the same value when we did it the other way. So now I'm going to plug that in for y, plug in 3 for y, oops, not for x, for y. So plug And when we do that, we're going to get x plus 6 equals 8, and so x equals 2. Same exact answers we got using that reduced row echelon form, both by hand and on the calculator. See how it ends up being the same answers. It's pretty much the same process, whether we do it with the RREF method, elimination, the calculator doing it for us, it's all the same. So now we're going to look at this complicated matrix that I told you we'd be able to work with. So doing this, trying to get this in RREF form, reduced row echelon form on our own, be tough. We'd have to get the one, we'd have to get 100 number, 010 number, 001 number. Really complicated, but the calculator will do it for us, which is great. So we're going to go to matrix. We're going to go over to edit. This is a 3 by 4 matrix. We're going to go ahead and write it out. What would it be? So it'd go 5, 2, -4, 0, -3, -4, -2, 6, 6, 7, 5, and 15. So we can see that that's a 3 by 4 matrix, 3 rows, 4 columns. So we're going to go ahead and put that in. Make sure you're real careful, 3 by 4. Okay, once we have it in there, we want to make sure that we hit quit now, not clear, but quit. Just double check, make sure you put it in right. Yep, looks good. We can go ahead and clear our screen. And now we're going to go back and find that RREF. Now we could actually even do a second enter since RREF is the last thing we did. But we'll go to math, and just to kind of review that, that's going to be down there a little bit further. So I can go down to RREF, and we just made it pop down to B because that's where we remembered it was, but you can scroll down. And now we have to go back to matrix, and I've got to find my matrix. It's an A, push enter. And once we push enter, it gives us the solution. Now you can see how complicated that would be to do by hand with all the fractions we're getting in there, decimals. We can have the calculator convert this for us just by doing that math frac. And so you can see that 100010 that I was talking about with that RREF. So once we frac that out, then we've got our X, Y, and Z's. And we know what those are going to be, so we just jot them down. So X is going to be 44/3, and you can just leave it like that. In math, we used to call those improper fractions, but you know what? They're not really improper. Just because that numerator is larger doesn't really mean that it's wrong or anything. So we'll just keep them in this form. And there we go. X, Y, and Z are those points. Those are the only values that will work. There are infinitely many x, y's, and z's that could work for any one equation, but there's only one solution that will work for all 3 of them. And that's it. If you have any questions, make sure to email me or ask me, and we'll make sure you get it down.